Let's take a couple minutes to define what a circuit is and kind of how we can think about it. So with a circuit is a set of paths, and those paths will usually be formed by wires. So typically we're talking about a collection of wires that allow charge to flow through a complete loop. And what we mean by a complete loop is that it can start at one point, move along the wires, and come back to the same point. So your most basic circuit would be something like a battery connected up to a light bulb, connected back up to the battery. So if I have a piece of charge starting here and it moves along, it can go into the light bulb, through the light bulb, come back out, go through the wire, through the battery, and back to where we started. So that's an example of a circuit. Another example of a circuit might be something that looks like this. So two light bulbs hooked up. To a battery. So in this case, again, if I have a charge that starts here, it can move along. It can choose to go through either light bulb. So we'll go through the bottom one, loop back around, come through the battery, and get back to where it started. Likewise, it can also go through the top, loop around, and come back. So this is an example of a circuit because there is a way to flow through it. And it's a complex circuit because it actually has these two paths that it can go through. But that's the idea behind a circuit, is if you can kind of trace a path all the way through somewhere, that is an example of a circuit. So now, when we start talking about circuits and when we start talking about the different types of circuits, something that is often useful is an analogy of pipes with water flowing through them. So imagine a loop of pipes carrying water. In that case, the voltage, so that would be I'll draw an example here. So we've got a pump station here, and it's gonna pump water up to the top of a hill. And then that water flows out and, goes down the hill and comes into a lake and then goes back into the pump station. So this would be an example of a circuit for water, right? The water can start here, flow all the way down into the lake, go up the pump, and then get back to where it started. So in this example, the voltage would be represented by the height of the pipes, or the height of the water. So something that's at a high point would have a lot of voltage. Something that's down low would have a low voltage. The current in this example is represented by the amount of water flowing through the pipes. So that can have high current either because it's moving quickly or because it's a big pipe. And we don't really worry about that distinction we don't worry about that distinction too much for actual circuits, but it will help explain some rules that we'll talk about eventually. And then finally, resistance is represented by something blocking the pipe and trying to slow the water down. So if there's like some sand in the pipe, then that would mean that that section of pipe has a higher resistance because it's going to slow down the water flowing through it. And this analogy we'll talk about a lot more as we get into calculations and kind of doing stuff with circuits. But I want to show an example here. We'll do kind of some illustration here, and I'll show you a circuit and kind of the equivalent analogy. So don't worry too much about some of the details that we're going to talk about. So let's actually start with a circuit. So we'll talk about this more as we go forward, but this is a circuit diagram. And what we have is a voltage increase. So this is a battery, and these are resistors, or things that make the voltage drop. And so what this would look like if I were to draw it in my water analogy here, I'd have my pump station. This is the battery. This is a resistor, which will cause, and again, we'll talk about why these things happen later. But for now, just know that resistors make voltage drop. So we have a battery that pumps the water up. It increases the voltage, so it makes the voltage go up. It makes the water go up. Then it flows out from there. And then it flows along during this whole wire. It's keeping it the same level because it's just, moving along horizontally. But then this resistor makes the voltage drop. So this would be our voltage drop, or we can think about it as a waterfall in our example, or a pipe that's going down. So that would be the first resistor, and then there's some wire where it keeps the same voltage for a while, and again, don't worry about why we know these things. And then we have a second resistor where it drops again. So these are our two resistors, are these two waterfalls. And then at the bottom, it flows until it goes back into the pump and goes back up and flows through. So this kind of helps you to maybe see or imagine. As we talk about the actual examples, I'll also go over this again and again and again, but I wanted to give you an example to start, so it's kind of planting some seeds.